हेलो एवरीवन। आज हम मैट्रिक्स की बात करेंगे जो कि बीएससी सेकंड सेम का सिलेबस है। ओके, सो फर्स्ट ऑफ ऑल, व्हाट इज मैट्रिक्स? So a matrix is a representation of m by n numbers which may be real or complex in the form of a rectangular array. It's called matrix. Okay, so a matrix is represented by Aij m by n. So here we see that here I represent the number of rows and j represent the number of column, and this represent the order of a matrix. So if we have a matrix of order m by n, then we say that this matrix has m rows and n column. It means here I varies for row and j varies for column. Okay, is that clear? Okay, the representation of m by n matrix is given by this. Okay, so here this is m by n matrix. So the first element is a11. It means one row, first row and first column. This represent the elements of first row and first row. Okay, so this is the representation of matrix. I think you got what is matrix. Is that clear? Now we go for types of matrix. So first we have null matrix, or we say it zero matrix. So a matrix of order m by n is called null matrix if it contains all mn elements 0. It is denoted by O and it's usually written as Aij m by n equal to 0, 0, 0. If I say to you, suppose we have a matrix like that 1, 2, 3 and 4, and if I ask to you that how many number of elements in that matrix, so to find the number of elements you can easily find by mn. Here m is the number of rows and n is the number of columns. So here we see that there are two rows, 1 and 2, and there are two columns. So the number of elements in this matrix will be 2 multiplied by 2, it means 4. So you can find the total number of elements in matrix by using this. Okay, so if we have a matrix which have all elements are 0, then we call that matrix is null matrix. Okay, so now we go for row matrix. Row matrix, if a matrix having only one row and n column, then is called a row matrix of order 1 by n. Okay, so here n is the number of columns. It may be 2, 3 and so on. Okay, so is that clear what is row matrix? Now we go for column matrix. A matrix having only one column and m rows is called a column matrix of order m by n. Okay, so this is m. Is that clear? If we say that if we have to make a matrix of order 3 by 1, so we can easily make it like that 1, 2, 3. So here we that there is only one column and there is 3 rows. So the order of that matrix will be 3 by 1. We always write the order of any matrix as first we write the number of rows and then we write the number of column. If we have a matrix of 3 by 4 order, it means it have 3 rows and 4 columns. So is that clear how we can find the order of that order of a matrix and how we can find the number of elements in a matrix? Is that clear? Okay. So now we go for next concept, horizontal matrix. So horizontal matrix, a matrix having more columns than the numbers of rows is called horizontal matrix. So in this example, we see that here the number of rows is 2 and number of column is 3. Okay, so we call this matrix is horizontal matrix. Okay, here we if we find the order of this matrix, so order of this matrix is 2 by 3 because it have two column, it have two rows and three columns. So is that clear? Now we go for fifth point, vertical matrix. If a matrix having more rows than the number of columns is called vertical matrix. So in this matrix we see that here there are 3 rows and 2 columns. So this matrix is called vertical matrix. If we find the order of this matrix, so the order of this matrix will be 3 multiplied by 3. 3 multiplied by 2. Yeah, we can say that the order of this matrix is 3 by 2. Okay. Now is it clear? What is horizontal matrix? What is vertical matrix? Okay. So now we go for next. Square matrix. Square matrix have if a matrix having number of rows to equal to number of columns is called square matrix. Okay, if we have a matrix of order 3 by 3, it means it have 3 rows and 3 columns. So then this is a matrix of order 3 by 3, which is square matrix. Is that clear? If we want to find the, if we want to write the matrix of square matrix of order 2 by 2, so we can write like that. It means it will have 2 rows and 2 columns. We can make like that 1, 2, 4, 5. So this is a square matrix of order 2 by 2. So is that clear? What is square matrix? Now we go for diagonal matrix. A matrix of order n by n is called diagonal matrix if it contains all its off diagonal elements equal to 0. It means here we see that this is the diagonal, okay, of the principal diagonal of this. And if remaining elements are 0, then we say that this matrix is diagonal matrix, like that. If suppose we have a matrix A is equal to Aij n by n and Aij equal to 0 for all I not equal to 0, then A is a diagonal matrix of order n by n. It's usually written as diag of A11, A22, A33 and AN. Okay, so if we find the diagonal of this matrix, then this will be diag of A11, A12, was A11, A22, A33. Okay, so is that clear how we can find the diagonal of a matrix? So now we go for next, scalar matrix. A diagonal matrix whose diagonal elements all equal but not equal to 1 is called scalar matrix. Okay, sorry, in this all, if we say diagonal matrix, it means that only diagonal elements will be non-zero and all these elements will be. Okay. Now this is diagonal matrix of order 3 by. And here the value of k is not equal. Okay. So is that clear? What is this scalar matrix? So we can take one example. If we have a matrix of like that 2, 0, 0, 2. So this is a scalar matrix of order 2 by. Is that clear? Okay. Now we go for unit matrix. A square matrix of order n by n having all of diagonal elements equal to 0 and each of the diagonal element equal to 1 is called a unit matrix. It is usually denoted by IN and written as like. It means only principal diagonal elements will be 1 and remaining elements will be 0. Okay, if we want to write the matrix of 3 by 3 unit matrix, so we can write 1, 1, 1 on position of diagonal and on remaining position we write 0. Okay, so is that clear how we can make a unit matrix of any order? And usually we denote a unit matrix by I option. Okay, so if you have any doubt you can ask. Now we go for triangular matrix. Triangular matrix, a matrix in which the elements lying above or below principal diagonals are all zero is called a tridiagonal matrix. There are two kinds of we call triangular matrix. Okay, so there are two kinds of triangular matrix. First one, upper triangular matrix. A matrix of order n by n is called an upper triangular matrix if it contains all its elements below the diagonal element equal to 0. Okay, it means if we have a matrix like that. So here this is a diagonal. Here the elements below this diagonal are 0. So we say that this is an upper triangle. Okay, so is that clear? Now we go for next. Lower triangular matrix. A matrix of order n by n is called lower triangular matrix if it contains all its elements above the diagonal elements equal to 0. So here we see that the elements above the diagonal are zeros. So we call this is a lower triangular. So is that clear? What is lower triangular matrix and what is upper triangular matrix? Okay. Now we go for operations on matrices. So here first operation is addition. So how we add two matrices? If suppose we have two matrices A and B of same order, okay, we can add only those matrices which have order shape. Okay, then the addition of these two matrices is obtained by adding corresponding elements of A and B, and it is denoted by A plus B, if the order of A and B is m by n, then order of A plus B will be m by. Okay. Suppose we can write A as A is a matrix of m by n and B is a matrix of m by n, then A plus B also be a matrix of m by n. For example, we have a matrix A is this 2, 1, 2, 3, 4, 5, 5, 6, 7, and B is 2, 4, 6, 3, 4, 5, and 5, 6, 7. And we have now we find A plus B. Okay. So first of all, we see that the first element for adding these matrix. So we add first element of A with first element of B, which is 2, and this is 2. So 2 plus 2 is 4. The second element is 1. Second element of first row is 1, and second element of first row is 4. So 1 plus 4 is 5. Okay. Now third element of first row is 2, and third element of first row B is 6. So 2 plus 6 is 8. Okay. Now we go for second row, and first element of second row is 3. Here first element of second row is 3. So 3 plus 3 is 6. Second element of second row is 4, and second element of second row is 4. So 4 plus 4 is 8. Third element is 5. Here third element is 5. So 5 plus 5 is 10. Here first element of third row is 5, and here also 5. So 5 plus 5 is 10. And second element is 6. Here second element is also 6. So 6 plus 6 is 12. Now third element is 7. So 7 plus 7 is 14. So is that clear how we can operate addition operation on matrix? Okay, so is that clear? Now we go for second operation, which is subtraction. So subtraction of two matrices. If we have two matrices A and B of same order, then the subtraction of these two matrices is obtained by subtracting corresponding elements of A and B, and it is denoted by A minus B. If the order of A and B is m by n, then order of A minus B will be m by. Okay. Suppose we have a matrix A like that and matrix B like that, then A minus, sorry, this is A minus. So A minus B will be Aij minus Bij of order m by n. For example, if we have a matrix 2, 1, 2, 3, 4, 5, 5, 6, 7, and a matrix B is 2, 4, 6, 3, 4, 5, 5, 6, 7. Then how we find A minus B? So we subtract first element of A from first element of A of B from first element of A. So 2 minus 2 is 0, and 1 minus 4 is minus 3. 2 minus 6 is minus 4. 3 minus 3 is 0. 4 minus 4 is 0. 5 minus 5 is 0. 5 minus 5 is 0. 6 minus 6 is 0. And 7 minus 7 is 0. So is that clear? It means we have to subtract first element from first element. Okay. Means we have to subtract corresponding elements of A and B, and we get A minus B. Okay. So is that clear? So now we go for next. Multiplication of a matrix by a scalar. Okay, so do you know what is a scalar? Scalars are 1, 2, 3, and so on. Okay, so multiplication of a matrix by a scalar. If we have a matrix A of order m by n and k is any scalar, then multiplication of A by A is written as Ka. Okay, this is capital A. Is obtained by multiplying each element of A by K. If we have a matrix like that Aij, for all I lies between 1 to m and j varies from 1 to n. So now we take one example. We have A equal to 2, 1, 2, 3, 4, 5, 5, 6, 7 and K equal to 3. So to find Ka, we multiply each element of A by 3. So this will come 6 to the 6, 1 3 the 3, 2 3 the 6, 3 3 the 9, 3 4 the 12, 3 5 the 15, 3 5 the 15, 3 6 the 18 and 3 7 the 20. So is that clear how we can multiply by a scalar on a matrix? So is that clear? So now we go for next. Equality of matrices. Two matrices are said to be equal if both have same order. Okay, having same corresponding element. Okay, then we say two matrices are equal. For example, we have two matrices. A is 1 2 minus 3 4 and B is x y z. So we say these two matrices will be equal if corresponding element will be equal. So here the first element is 1, so it will also be 1. So it means these two matrices are equal if x equal to 1, y equal to 2 and z equal to minus 3. So is that clear? Okay. Now we go for properties of matrix addition. So first property is commutative law. If A and B are two matrices of order m by n, then A plus B is equal to B plus A. It means if the solution of A plus B is equal to B plus A, like that if we have a matrix A is equal to 1, 2 and this is 3, 1. Okay, and B is equal to like that, B equal to 2, 1, 1, 3. Okay, so when we add A plus B, so this will come 2 plus 1 is 3, 2 plus 1 is 3 and 3 plus 1 is 4, 3 plus 1 is 4. Also we find B plus A. So 2 plus 1 is 3, 1 plus 2 is 3, 1 plus 3 is 4 and 3 plus 1 is 4. It means both are equal. It means we can in a commutative law A plus B is equal to B plus A. So is that clear? Now we go for associative. If A, B and C are three matrices of order m by n, then first we add A plus B and then we add C, and this is equal to first we add B plus C and then we add A. So this is associativity. Now we go for additive divided. If A is a matrix of order m by n and O is a null matrix. Null matrix means zero matrix. Means a matrix which have all entries zero. Okay, of same order. Then A plus 0 is equal to 0 plus A equal to A. So is that clear? We can take one example for this. We have like that A is equal to 1, 2,